Hello, welcome. I'm Bill Wake, back from a week of actual travel, first time in over a year. We're working on, we started working on recursion and did this Tower of Hanoi problem where you slide the disks around and developed a recursive solution. But my deeper interest is doing some work around algorithm visualization. And we did a very primitive visualization of this. I thought I'd go a little deeper on the visualization, not so worried about recursion, but just kind of getting the mechanics down of how we can visualize things. And part of that is this challenge of threads and the way Swift keeps track of, like many frameworks, you have to update UI components on the main thread. And we've been playing with variations around that, and I don't know. It's not right yet. I'm not quite sure what the right thing to do is. So, um, one of these stumble around in the dark a little bit kind of episodes coming up, I'm afraid. But I thought basically we'll have two problems, threads and visualization. And when I get so frustrated with one, we'll just bounce over to the other. And then hopefully between them, we'll get something done. Okay. So let's see. I guess we can see where we are with this. So we have this notion of a tower, and we've made it observable object. So that's that's a kind of publish subscribe mechanism, and we've identified certain things as being published. So the ticks, which is how much we're slowing down, the number of calls, just to get something to visualize, and the contents of the pegs. So there are three pegs. You're moving these disks around, and when they update, we want to see the new stuff. So we've got something for the individual pegs and then the pegs as a whole. We played around with some caching and some other stuff, but I think right now our solution, is really just a simple recursive solution. We move all but one of the disks to the intermediate peg, move the bottom disk over to the final peg, and then move the intermediate disks back to over to the final peg. And we developed some variations that used an approach to getting rid of recursion, or at least some recursion, and so on. I'm not planning to explore this aspect anymore. It's just I've got something to visualize. So I ran tests already, but let's run the app. All right. So you can see the number of calls, and then this is peg A, B, and C, our three stacks we have. And when I say go, they should start moving around and we should see them shuffle. I don't think we exactly see everything going on. I'm a little concerned about that, but the moves it makes seem to be the right moves. So let's see. I think I hit go. Three calls, four. Yeah, so we're not seeing any updates at this point. Okay, there's one. Moves five, moves four. Now we're going to move five over, move three to the final target. We'll have to move one and two. Okay, so we got five. I guess five is the littlest. It's a little confusing. One, two, five. One, two, three, four. There's five now moved. And we're seeing the pause as it moves. I think we're seeing all the steps. One, two, five, three, four. It would certainly be nice if I could drag the number over and stuff like that. But we're at very primitive levels here. Okay, so we got the four, one, two, three, four. We want to get five off. Now we got the big disc one, and we'll move that to the far peg. And then we have to move the little discs on top of it. Okay, so we got everything on the intermediate peg, and okay, 5 4, get 3 over, put 4 5 back on the I guess put 5 back on the intermediate. We want the 2 peg there. So 5 is going to go on the top, then the 2 on the bottom. Okay. And then the 3, 4, 5. Okay. And it's always 2 to the n minus 1 steps. So 3 will be 2 to the third is 8, minus 1 is 7. Okay. 3, 4. There's the 5. Move the 3 down. Move the 5 out of the way. Using the top peg as the intermediate. And then move 4. And then move 5. Okay. So I guess at the slowness of it. All right. So 63 total calls. Again, 2 to the nth, 2 to the 5th. Maybe it's 2 to the n plus 1 minus 1. We depends on the level. So, yeah, we had a version that knew moving disk 1 was doing nothing. This version, it knows disk 0 is doing nothing, but when you call it with 1, it recursively calls move 0 and then that. But we could. And we had a version at one point. I don't know if we still have a copy of it. Yeah, we did something like this. If number of disks equals 1, okay, cuts down about half of the things. Now the challenges we have here. Okay, we got the pegs and the updates and that, but then we get, hey, publishing threads changes from background threads is not allowed. Publish values from the main thread. And let's see. So the problem is, let's find our go button. Okay. So right now we're telling it dispatch. Basically, we're using a thread here. So dispatch queue global says make this call in the global thread, and so when it does that, tower.move, well, that eventually calls, it calls our tower, our stack methods. Let's get down to it. So tower.move eventually calls tower.move1, which touches pegs. And that means that they're being touched in this global thread rather than the main thread. Okay, there's 2 threads involved at this point. There's global and main. We could call this in main. Let's see what that does. Okay, and we'll run that again. Oops. Non-function type. I guess it's just doesn't need parentheses. It's just a hard-coded thing. Static field kind of thing. Okay, so this time we're updating them in the main thread. Okay, so our dispatch of move 5 pegs, move 5 disks is happening in the main thread. And so the challenge is, what happens is nothing's updating because it's all waiting for that first method call to finish. Okay, so doing this in here, they're happening. The changes are happening, and even the UI system is finding out about it. Update received is this on receive call. It knows stuff is going on, but it can't refresh the screen until it finishes this call, and that call is the overall thing. So everything's happening there at once. So I'm not sure there's going to be a great solution, and I'm willing to get my algorithm pretty ugly looking if I can use that to, if I can kind of find a pattern where I can just modify an algorithm, write it properly, make it ugly meaning put in thread calls and stuff like that, and have it work, I would be okay with that. I want to get rid of these warnings, but notice this version does get rid of the warnings. It's not complaining about stuff coming in on the wrong thread because it's all coming in on the main thread. And I think at the end we'll see the 1, 2, 3, 4, 5 get moved down there, but we won't see all those intermediate updates. And what are we on? 49. Okay, so we got to get up to 63. All right, come in. So my idea is basically I want to find the published fields that are the things I'm trying to visualize. Yeah, there we go. It finally finished. I want to find the published fields that I want to visualize, and I want to do the update in the main thread. And I think that will basically run stuff in the global thread, but then in the main thread, update the pegs. And then when that finishes, the UI system will have a chance to go update itself based on the published stuff. And I'm hoping it will work. So let's go back to global. So I think what I want to see is I'm trying to run this in the global thread, and maybe I should be creating my own thread. That's another question in my mind. But I want to make sure that the calls that affect it, like this stuff, pegs remove last, pegs append. I would like that to happen in the UI thread, so that these published changes happen over on the UI thread. All right. I think rather than drive myself crazy on this twice as many calls as we need, let's go steal that other version. It was somewhere down here. Well, I guess it was kind of like this. Oh, this version was the memoized version, so it had a cache. We're just going to steal from that. Okay, so if the number of disks is 1, else I'm going to return let the rest of it run. Okay. Okay, so if it's greater than 0, if it's equal to 0, we're going to return empty string. Otherwise, we're going to return the move 1, which is the middle, and if it's more than 1, we're gonna use the intermediate peg. Okay. And then I think the ticks. This is microseconds, so let's make this 1 second between moves. All right, so I should have just sped things up by a factor of 4, something like that. All right, so let's try this. We're back to the global thread version, so we should be able to see it. It should be a bit snappier, and it should only need 31 calls. Okay, so hopefully things start moving around. And I guess it's working its way down a few, and then now it's moving. Okay, so yeah, this is a little faster, a little better. And maybe I should be cutting it down even more because we don't really care about the feel of it. But we're back to this main thread. Here's all these complaints. Okay. And while that's running, let me look up Swift thread. Let's just see what we got there. I want to see, well, I kind of wanted to see Apple's documentation. I guess I'll put Apple in there and hope for the best. Thread class. Yeah. So, okay, you see 31 calls and it read faster. I'm hoping there's an async call. Is that what we called over here? Yeah, dispatch queue global async. Am I on the right? Not found. Where's main? Thread.main is a thread. Let's see if we can get to thread. Okay. Okay, what's going on? Global. I would have thought if main is a thread, it's the NS thread object. Well, where's... Oh, let's look up dispatch queue. Okay, there are FIFO queues. You can submit tasks in the form of blocks. Yes, either serially or concurrently. So, synchronously executing a work item on the main queue results in deadlock. Well, that's not good. There's async. Immediate execution returns immediately. Sync submits the execution and returns after that block finishes. Or you can submit a block and return after the block finishes. Yeah, it's all kind of the same. Okay. That statement up there gets me nervous because that's kind of the scheme I had. So what I was thinking was this would spin off the asynchronous of the whole thing. You know, run my tower program, run it asynchronously, you know, spin that off, and then I'm free to go back to updating the graphics. Okay, you know, because this just spins off. Now, what I was hoping I could do, let's borrow this, and which it seems to be saying I'm going to get deadlock. I was hoping I could do this. Main sync and that. Okay, so let's format that. I wish it left me in the same place when I formatted. Publishing changes from background threads is not allowed. Publish values from the main thread when model updates. Okay. So what I've done is I've added stuff. Our previous version published from that global thread. I'm saying I want to publish stuff from the main thread. So I'm going to move the pegs, remove from the last and append to the next. And I want to do that on the main thread and wait for the result. And this seems to be what it's saying is going to blow up. Or deadlock, which is even worse for us. Okay, so go 5, and then start moving. Oh, hey. And are we getting complaints? Oh, we are. Oh, but maybe that's because we have other stuff that's not being done that way. Um, we have to wrap every call. All right. So this is the right idea. Well, I don't know if it's the right idea, but it's the deal is we got these things. I shouldn't have to do all this. This is what's making me nervous. So I wish, if any of you all know what's going on, I always welcome. So I wish. Oops. If any. So sorry if any of you all have ideas, please speak up. But one thing I'm seeing is I don't really need this delayed ticks to be published. It's sleeping, but we're not displaying it anywhere, so I don't need that to be one of these. But this thing that gets incremented. All right, so let's try the same thing here. So I'm saying anything that changes publishing fields, published fields, I want to wrap in a main sync call. And it's sync because I'm going to wait, I want to completely return from it. It doesn't matter on this one so much, but this, like, I can't go on in my algorithm until I've actually done the move. So if I called it async, it would, it might go down 3 more steps in the algorithm, all these things piling up or something crazy. Not good. Okay. But I think we have fewer complaints, maybe not. I guess this is what we'll find out. I see updates received. Okay. And the bad thing on this is nothing's telling me, right? I mean, this is well, here these move 1 has its own, is the only thing touching the disks. These things just call this method recursively until they're ready to call move 1, and then it takes care of the disks. If I were displaying the output, then I would have an issue. Okay, so now I believe I've wrapped everything with this. Let's do that. Okay, are we getting complaints? We're 4. Oh, something. Sorry, let's run again. I also don't think we're set up to reset automatically, and I think I just ran the thing without running recompiling. All right. He died about 5 calls in for 5. Now we're okay. Yeah, we got to work on a reset as well. But are we getting complaints? No complaints. Okay, so now, we're kind of, I don't know if you want to call it a spike or not, but I didn't know the exact solution, and now I have a solution. Now, can I make this thing better? I don't know. I do have this feel. Well, these things aren't doing anything useful, I don't think. These on receives, they're just proving that we get the stuff. So let's try a version where we take these out. And we'll run this again. Next time I'm going to reduce it to 3 pegs. 3 disks, rather. Maybe 4, just so we have a different number of pegs than we do disks. 3, 4, 5. Here's 1. We're going to get 3, 4, 5. We're trying to get the first peg empty and the last peg empty. Well, the first peg, yeah. We're trying to get this. Now we got to move things off so we can get the 2 on the disk, on the stack, and then the 3, and then the 4, and the 5. Okay, so let's I think this is. I don't think we need this. Hopefully, I can reproduce it if I need to. Bum, 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 ba-dum. All right. Well, that's an improvement. Let's make this 4 discs. That was in here. Move 4 discs from 0 to 2. We'll run it one more time. Huh. Why is it 5? What's going on? Tower. Move. No, I messed up something. Was there initialization? Pegs, dot size, init size. Where's tower created? Ew, yeah, that's kind of weird. Like, why do you need that in both places? All right, well, let's try again. All right, 4 discs. Takes a few calls to get into it. So it's calling that recursively down until it gets to the bottom. First move 1 and then makes it go 2 and then 4 over and then 3 moves and 4 goes in. Okay. Yeah, and 2 to the nth minus 1. 2 to the 4th is 16 minus 1 is 15. All right, so let's check this in. So what we've done is we've made the original call on the global thread and all the updates to published fields on the main thread. Eliminates the warnings. I guess that's enough. Maybe runtime warnings. All right. So I guess this is where it's like, well, what's gonna make this work? See, the thing, well, there's multiple things going on. I don't know. They all bubble around. One thing is, like, we had a stack, a perfectly fine stack. It's got a stack of stuff, type T, in an array, and it had push and empty and pop and all that good stuff. But we couldn't use it directly because of update issues. But what I would like to do, if what I had, I would be content with, I guess maybe is what I should say, if I had a data structure that a sort of visualizable data structure that took responsibility to run stuff in the right thread and publish it and all that stuff, and you start it up in your own thread. That would be okay. But like, and then there's another issue too. It's like I'm publishing them in here. If I publish it as a stack, I've got to do some sort of notifications from the stack as it changes. That's built in here because the system array class knows when it's published. It should do these notifications. but like now I have to make sure when I do these modifications, I have to make sure they're all being done in the main thread. And also, I think something else that's going on. So before, if I did this in the main thread, I was okay. It just all ran and didn't do updates, and then at the very end it did an update. I think this one, if we run it like this, I think we'll get that deadlock that we were warned about. This bit. Because we're calling our UI from the main thread. Yeah, bad instruction. Doesn't tell us quite what that instruction is, but I think the issue is we're deadlocked. We're trying to call ourself. We called this whole thing from the main thread, and now we're saying, hey, call synchronously. Well, that's never going to work because we're already in the main thread. The main thread's busy. It's busy doing this stuff. Okay, so this is requiring us to do that global thing now, which I can kind of live with. I don't think it's crazy to say you run your algorithm in a separate thread and then notify back to us and we'll display it. I mean, that fits okay with it. But I don't like having the code for the syncing have to be sprinkled around like this. It just seems very unfortunate. And maybe the counter is the easy one to modify first. So my idea would be, instead of letting it just be a raw integer, I would make it a counter, a kind of wrapped type, and you can increment it and you can display it, get its value, and that's about it. But the thread stuff would be on the increment, and you would just be saying number of calls dot increment or something like that. Maybe that's a good place to go. All right. But I think what we've done, let's see. We're still in 2020. 2021-5-18, Rec-21-04. I think I'm just doing 2-digit numbers now. I'm trying to do shorter sequences. All right, so we're doing threads, and we're going to call our algorithm from the global thread, have it update any published fields from the main thread. So UI will update. Okay, and we've done that. Now the question is, can we make that better? All right. So my proposal is, well, okay, what would make that better? Yeah, I guess the thing to do, we'll stick with the thread stuff. It's in a way, the UI stuff is more pleasing to play with because you change something and it changes, and maybe it's wrong or right, but you can see what's going on. This stuff, but I guess what I'm going to say is there's a thing. It's a counter, and its characteristic is it's probably got a reset and an increment and a give me your number kind of thing. But it does these things synchronously. At least the modifiers have to happen synchronously. I guess the readers don't. Okay, so, and that means we would have to do some work on the actual object to make it notify. And I know I've been down this route and it just doesn't stick, but there's it's like cancellables. You set up a list of cancellables, and then you make sure to notify when something changes or something like that. So we'll find our way through it. But in the end, I want to publish, but I don't want it to be a simple type or a system type like these. And we have to do it for the stack eventually too, but I think it's easier to mess with a counter than it is with a stack. Okay, so what we're going to do, I think what we'll do is we'll implement it in parallel to what we have and see if we can get it to the same level. And if we can, then we will if we can get it to the same level, we'll just swap out and use the new one. Okay, I'll just call this numCalls equals counter of 0. All right, counter doesn't exist. Let's create it. It's just a Swift file, and it's a new class. Okay, and class counter. Okay. It needs an init. All right, and we don't have to do anything at this point. Okay, so I don't know. This is not. It's not how you normally think about TDD, but it's sort of a way you can do this algorithm, replace algorithm refactoring, I guess you would say. I'm going to run tests instead. I don't think anything will. We have too little here to be of interest to our tests, I think. Okay. So, well, there you go. Oh, because they run on the main thread. Ugh. Yeah, this is the kind of thing. It's saying we have to run our algorithm on the right thread. Golly, what would be a better way to do this? So what's the issue? It's the number of calls. So number of calls is being run from that thread as well. Well, let's try this. All right. I have this bad habit of editing while I'm running for tests and stuff. No. Which test? Test with no disks. Okay, maybe they all. Do they all have to do this? That'd be very annoying. I don't even know if I can do these asserts like that. Notice passed. Okay, so I guess For now, we'll just do this. But having to do this all over the place is not my preference. Okay, let me commit that. And how about make tests run on global thread? Okay, we're at break time, so let's take a break. I think we'll come back and let's get this counter class going. And maybe I should be testing him. Maybe it'd be better to get some tests in place as we go rather than piecemeal bring him into existence. So we'll come back and do that. So 2 or 3 minutes, grab a drink, whatever. We'll come back, create this counter class, and see if we could make it able to be put into the views. And if we can, then we can do that with the move with the tower itself or the pegs. And if we then have stacks that if you call it from an asynchronous thread, it lets you know interesting events on the main thread, that's a win. All right. See you in a couple. Welcome back. All right. Let's create a counter test. Well, I guess that should be down in here. And here we'll create a test. And this is counter tests. Now, we need to get the value back out somehow. So, do I ever want to... I don't know if I really need that initialize. The 0 thing. We're putting it here. Counter 0. It's like you could just make a new counter, but let's 0. Okay. And we want to say let counter equal counter. And we're going to assert equal. Well, this should be 0, and this should be counter dot value, I guess. All right, let's take this out. And where's counter? All right, I don't need an initial value, but I do need a value. I don't know how I want to do this. Well, let's just return -1, make our test fail just to make sure we're on a decent track. Okay, now, did that fail? Where's my counter? Oh, I didn't say test. Try that again. Okay. Let's get that. Now, okay. Well, increment updates the value. We definitely want that. Okay, so if we say counter.increment, and we're going to expect counter value to now be 1. Oops. Okay. Yeah, no increment. Let's add that. Function increment does nothing. Test should fail because nothing touches the value. All right. So to make this pass, we're going to have a counter here somewhere. Which, interesting, it's not a smooth change, right? All right. Now, I'm going to, well, let's just do this. I mean, I really expect this to be the value too if I increment twice, and I think that's good enough for what we want to do. Now, here's where we're gonna get ugly, and I don't even know. Oh, man. So what I want to happen with our counter is I don't want you to run it in the main thread. And if you do, that's an issue. I don't know that I have to be looking for that and enforcing it, but my test should do that. So I want counter.increment to be a synchronous operation on the main thread. And if you do anything to it, it should increment, and then anybody listening should update. Oh boy. Well, okay. And I think I'm invalidating this test. I'm saying this test is not legitimate because it really should be calling dispatch queue dot global dot async of this code. This is the proper way to run the test, and if you don't, well, I think this should still work. Let's check that first. But now if let's say increment cannot run on main thread. If I take this off, well, I expect an error. The problem is it doesn't catch the error and throw it for me, I don't think. I mean, I expect that bad instruction thing. How can I check? Maybe I have to check. Can I ask what thread I'm on? Not that one. Whoops. Oh, that's not Swift. Blocking the main thread, yes, that's a problem. Okay, there's the thread. If you scroll table. Well, that's all interesting, but well, that's not. I guess we'll just look for real thread itself. Run loop, there's thread. I think there's a static method that tells me what thread I'm on somewhere. Well, is main thread. Okay, I can ask this question. Returns a boolean that indicates whether the current thread is the main thread. So thread.is main thread. So I guess what I'm saying is this thing should return an exception. So test exception. And you have a okay. It's an assert of some sort. Let's see, XCT thread. Throws error. And then I think I just want to do this. We don't need it twice. I'm not sure this is quite what I'm after, but asserts an expression, throws an error. Generic priority. Try something. Can that be the right? It would seem like that has to be in braces, but apparently not. We'll just print it to get some bearings here. Okay, so this. So if I say throws, yeah, I hate that if you put any throws in there, you got to responsible for catching it everywhere, all over the place, all the time. It really makes things like this hard. And these are sort of like shouldn't happen situations, so I don't want to pollute my interface with try throws and all that stuff. Okay, well, what do I want to happen? I want to say count.increment. I mean, I want to say it throws an exception or it does something. I want it to blow up. And I think it will if I do this on the counter with main. So this is sort of what I want. I mean, I don't know if there's a better way to wrap it around all these things or anything like that, but reference to property counter enclosure. Okay, fine. I would like this test to blow up, but I would like to detect it. And it passed. I mean, is it a problem if it runs on the main thread? Not exactly. I don't know. I mean, as of now, my tests all run. Let's see, what are we? Can we start this thing in parallel? Well, now I don't have. I would like my counter to be an observable object. Okay, so that's fine. I don't think anybody's going to complain about this. What are you doing over here? Okay, yeah. That's kind of what I was expecting to happen originally. Is this the bad exception thing? Must be called on the main thread. Pthread kill, terminate. Ugh. Well, now I get my... What's going on? Now I get my failure. Oh, I don't even have that test there anymore. Counter. Yowza. What's going on? Did I not run the test in 13? I thought I did. Maybe I'm interacting with it because it's... Let's see. Let's take that out. Not the issue. Can we tell which test is blowing up? Stack test, stack pop can retrieve items. Must be called on the main thread. Pop can retrieve items. Oh, our stack. Even more. Stack tests. I wasn't even aware those were being used at this point. Now, why would they be problematic? Pop can retrieve items. Not good. Passes sometimes, fails sometimes. And I don't see any interaction that stack should have. Wow. Is this anything to do with observable object? You wouldn't think there'd be any relationship. Stack is a little standalone class. Let's just run these tests a few times. Okay, that's... They're running by themselves. Something I'm doing is spinning up... I'm spinning up a thread situation that confuses it. I don't think the print should be an issue. let's take these out of the running for a minute. Run them again. Seems like every other time is failing, which I would say is weird. Well, maybe not so much every other time. Let's see if it's... Is it just this one test that's doing the queuing? Let's try sync and let's try pulling this down. I don't think I care that it's sync or async, but I feel like this probably should not be. We're trying to run this in a different thread, and I think that's maybe if I had it in this block. I think the issue may be this assert equal trying to run it in the global thread instead of the main thread, when all this other stuff's in another thread, you know. So let's try this. Zero is not equal to 2. Async and wave, that's what I want. Not many results. Some of this documentation is just so horrible, Apple. Come on. Okay. Oh, man. Thank you so much. Well, somewhere I should be able to wait for a thread. Is that the right term? Kind of synchronously. You wait till you finish. Now, what was the problem with sync here? Huh. A dispatch work item. What is that? Well, X unit threads. Let's go back to that. Running tests in parallel. Running, that's not Swift. Oh, well, that's an idea. We could look at it and say, if we know we're in the main thread, return it. Otherwise, we're going to go to the main thread and run it. Gets that run only the main thread. Well, this part of it is definitely interesting. Thread save values. The main thread is synchronized access. They're running sync. I mean, what I'm appears to be happening. 0 not equal 2 makes it sound like the counter did not upgrade increment. Now, can I do a sleep or something like that? Sleep 4 time interval. Gonna give me any hints? Like, how about some units? Just saying creates a new value. Well, let's try 1,000. We had that sleep, that other sleep. Maybe I should use that. There's a second. So I think when we have it in here, something's going wrong. Well, this is why I hate threads, and you should too. Okay, is our counter still... Oh, this should be sync. I think we still might get a warning about threads, but maybe not. Maybe the async. Yeah, we're running this in the main thread. Increment updates the value. Okay. All right, let's run them all, make sure everything's still... I think to get what we did before, we ran stuff in the main thread synchronously, and now we're doing that here. Okay, well, it's time for another break. I guess what we're trying to think about... Well, maybe this is the right... Maybe this is the approach we need. But anyway, all right. So we got a counter. It only updates on the main thread. And I think we should somehow be able to publish it. This is where I got tangled up in publishing before. So I would have liked to have just said, you know, this is published, meaning anybody who wants to be a listener on it can listen for it, and it will happen on the main thread. But if you do that and then you use it in here, it's not, you can't like inherit that the publisher over here. Now I just want to publish it through. So there's something going on there, but we'll take a break, clear our minds, and do it. So 2 or 3 minutes. All right, welcome back. So where we are, we've got the counter object. If you change it, it updates it on the main thread. I don't know. Let's see what happens if you do this. We'll run tests first. Now notice nobody's incrementing that number counter, so I don't think there's a problem there. All right, now we don't have to do, here we're going to do that num calls. Increment should go off and run this on the main thread inside it. Right, that's happening there instead of on the outside. Whoops. Instead of here. I think that should be okay. And then we'll run the app and make sure. Now let's, oh, that was not the right one, but we've got enough flaky stuff. I guess it doesn't hurt. Let's try this one. Now my expectation is things just run. 2, 3, 4. Now it's moving. Yeah. Okay, so no harm, but we can't observe this increment. Let's put something in to print it. What I'd like to see is that thing increasing just like number of calls. Yeah, that's putting the information out, and it should get the same number. 13, 14, 15, right? 15. Okay, so this is good news. Why are you over here? You're supposed to be over here. All right. So where we are is we've got these two counters that are operating in parallel as we wanted. The second counter no longer requires its caller to do the synchronization. It does it itself. All right, now I think the step I want to take, I want to make this test run. And I want to make sure it can run on the main thread. And so at the end, counter.value should equal 1. Okay. Increment updates the value. Okay. And this is in another thread. One call from another thread. All right, so let's see what happens here. As far as I know, we're still going to blow up, but I think we're going to adopt that suggestion of the Stack Overflow answer, and we can say our routine is gonna do the right thing. Yes, that blows up. Bad instruction. Okay, but here is what we can do. If thread is main thread, and we ran across the description of that before. All right, so I want to say if thread is main thread, then do it, else do it in the dispatch queue. Is that good enough? Else return dispatch queue main sync value. I don't think we do need to return. I mean, this is a little ugly. I will grant you fully. But we will get it working. I hope. One more brace. Okay, if the thread is the main thread, just do it. Otherwise, do it in the main thread. Okay. Now this, I hope everybody's happy with. Cool. All right. Now we can refactor. So, well, how do we want to refactor? Can we say, can we do this? Can I do it in there? I'm just pulling that out in an attempt to get something I can extract. Yeah. Okay. So now this, oops. Let's extract a method. And this is run in main thread. All right, and now I can inline this closure. Well, let's take it a step at a time, right? All right. This should be able to be there instead of this. Okay. And to tell my story from top to bottom, let's do it that way. Okay, so I have a counter, I have a value, I have increment. Increment runs in the main thread either because it's already there or because it sets up a dispatch queue. Cool. I mean, this is... The code then run in main thread could probably live somewhere else. We'll have to in the long run. Okay. I feel like that's a good step forward. So increment can run on main thread. Let's make this test the first one. And I think this is increment can run from another thread. Okay. Now I see this is a reusable piece when we get to our stack. But I think we've solved the big problem. Let's run these tests like 3 times. Just to make sure. I mean, threads are so fraught. It really is a painful thing. But I liked that. That Stack Overflow definitely was helpful. Okay, so where we are, we've got this all happening on the global thread. We come in here, we're definitely counting the number of calls correctly and updating it on the main thread. So we think that anybody listening would be fine. Now we have to deal with, how do I listen? I would like, well, okay, we got this thing published. Let's show it on our screen. All right, so just like we did up here, we're going to put another I don't know how to make this look special. Number of calls prime tower dot num calls. No exact matches to append interpolation. Number of calls is, should be dot value. Num calls dot value. Okay, and let's run this. Oops, run. Okay, they're both there. Let's see what happens on the updating front. Oh, he's behind, but he's moving. Okay. Maybe we're okay. That seemed all right. All right. Can I trust it enough to delete this? Let's do that. I'll take the prime off. Run that. Now no one's calling that original counter, or I mean, no one's looking at it. We're calling it still. I didn't see 3 come by 9. I feel like it's skipping something. We're maybe missing. I don't know. Well, that's something to deal with, I guess, if we need to. I don't know that we're guaranteed. I mean, it's all in that kind of React style change, right? We're changing the presentation, and if things get behind and just has to get the latest snapshot and show it, it's got the full information. So it's a little hard to know. But I think we're moving. I think we can do this. And then this code should go away. Okay. And then I just want to rename that to number of calls. Number of calls. Value. Okay. Let's run tests. Run the real thing. Oh. Well, I don't think there's anything to do. Tower number of calls is already assigned. So I think that's kind of redundant. That may have been my attempt at a reset. Let's run tests. And run the app. Okay. Let's commit. All right, so we added a counter that calls its modifier method on the main thread. All right. Well, we've done a fair bit of thread stuff. Let's start seeing what we have to do on the stack to make this a little nicer. I mean, one thing I can see. Let's put this back in and see what it was doing. I think they're going to read sideways. I'd like the numbers to be normal but not rotated. Yeah, that's a little weird. It's not horrible if the numbers were turned around. I could live with it, but okay. So the problem I have, I would like these things to be aligned to the left, because the thing I see that's funny, again, I'll have them up there. As they change contents, they're bouncing all over the place because they're defaulting to centered. So I think can I just alignment guide? Okay, well, Swift UI align text left. Set the frame alignment. Huh. Okay. Would have taken me a while to guess this. Okay, let's see how that's looking. They'll probably be hard left, yeah. But maybe that's okay. If it was 10 discs, I'd be very happy with that. Yeah, that's definitely more what I want. Okay, let's well, let's see. Let's try moving these down. Whoops. Trying to put the padding on the outside, maybe get a little more padding on the left. Yeah, let's. We're going to get rid of that duplication in a minute. Try to make a little more. I don't think it made a difference. Okay, so one of the things you can do with Swift UI is each one of these things that's its own deal can be a view by itself. We just had to pass. I shouldn't say just, because this is, oh boy. State object. This is where you get tied up with bindings and all this stuff, and I'm, ugh. All right. I should be able to extract this into a single view object that represents the stack. And I don't think there's a refactoring for it. Well, I can say struct my stack is a view, some view is a view. Okay, I got to give it a body of some view. And in that body, We want something like this. Okay. Now the text, this thing, I have to I'm going to have to pass in somehow. And oh, did I make a little chart for this? This thing that has burnt me over and over and over. No, not on this one. Okay. Let's look at Swift UI state object. Understanding a state object. Okay, that's promising. All right, so state object is the property wrapper, different than observed object. There's observed object. Oh, if you'd gone the extra step and just tell me how to fix it. I mean, this is saying you have it somewhere else. I mean, it's an independent object. It's the top level thing, and then when you create the child tower, not in scope. I mean, I would like to say my stack tower.peg sub 0. And this is, let's do that. And now I should make a stack here. And then this becomes stack.description. Okay, now, so I have my stack. I have the actual stack. It default puts an initializer that takes it. I just don't know if I'm passing it in a way that will get updated. So let's run it. We'll see 4 stacks now. The first 2 are the same, we hope. And then we hope they stay the same as it updates. All right, they are the same to start with. Let's say go. Did it go? Okay, they are keeping in sync. Okay, so apparently I'm doing the right thing. Passing it in. Okay, so now I can get rid of this duplication. My stack power sub 1 and 2. That should take the place of all this. And it should just work. And I feel like we're skipping numbers and not seeing things quite as quick. It maybe it's, I don't know, we'd have to check, but maybe it's not showing numbers where the screen down here didn't change. Is that possibly what's going on? But I don't know. This is one of these things I'm learning as we go. Okay, so let's see what else we did. We added a counter object designed to update itself only, or update itself on the main thread, regardless of which thread it's called from. that seems true. All right, the visualization stuff. Well, I think what we've done is we created a my stack Is that a true summary? Display int as a horizontal stack. Okay, that seems legit. Let's go back here. And that's pretty good. Now can I do this with a for each? For each tower.peg a. I don't know if this one's showing up. Not really. Okay, let's take this out. And then see if we can do, well, I don't know if I can do the same thing here. Oh, I can do those. Okay. For each. So I'm expecting 2 copies in my stack. Ooh, that's good. All right. Okay, so let's leave a question on our thread stuff here. Threads. Are we updating the counter only when the stacks change? We should update it every time the counter changes. Okay, but this one I think we have done. Let's try one more little trick here. 2's kind of a magic number. It's really tower.pegs.count. I'm not going to keep this rotation. We can find it again if we need it. So as it, oh, not to be. Oh, how about that one? All right, let's run it. I've never seen the 6 come up. Okay, 4, 5, 7, 8, and then 11. Yeah, it didn't show 9 and 10. I don't know if those are calls that don't change anything. All right. Um, cool. The visuals, I mean, the appearance is what we expected. Um, My stack can display int as a horizontal stack. Okay, that is done. We still have this open question, but I think this is a good time to stop. I'll just check these things in. Cleaned up. So there's a separate my stack content view. Okay. I'm not quite sure what to do next time. We'll continue on this. We'll probably go down both these tracks, visualization and threads. So thanks for joining me today. Hope I can catch you again. Next time is tomorrow, Wednesday, 9 to 11:30 a.m. Eastern Time. So if you can join me again, appreciate it. Thanks. Have a good evening.